I want to show you some basic features of the Python sddk package. Python sddk package was designed to work with sciencedata.dk data storage. If you don't know sciencedata.dk, look into package documentation, and there is a link to the documentation of sciencedata.dk where you can find all relevant information. For testing purposes, we will use Google Collaboratory environment. The advantage is that the package is not there, so you can see also the installation of the package. And everything is online on cloud, so that's also very suitable for working with the cloud data storage in couple. So first let's try whether the package is here by running an import. Yeah, we see that the package is not here, which is completely fine. So we have firstly to install it, and in between, before it's completed, we can start to assign a configuration variable, which is the syntax for it is like here, configure, and let's run it. This configuration asks us interactively for entering our username at sciencedata.dk. In this case, I will use my user account at the University of West Bohemia, which I do not use regularly. That will enable me to test some features with shared folders. So at this point we have a variable called configuration, and it contains our username and password together with endpoint at sciencedata.dk, where we can read and write files. Now, so the key features of the package are two functions: read file and write file. So we will start with write file, and then we'll move to read file. So let's imagine that we have a string object in Python like this, which contains some words. And we want to export this string to some file. So we have to specify the name of the file, the file type, actually what object we want to export. So this is this string object, and what configuration setting we want to use. So in this case, we will use this conf variable. And voila, we just exported the string object into this file at sciencedata.dk. We can check it right now. This is the web interface of sciencedata.dk, and you can see here the file. So let's move back to Python, and let's try to read the object back to Python. So for that we can use read file. Again, we have to specify the name of the file. In that case, we have to specify the Python, not the target object to export, but the target type of the object we want to import back to Python. And again, the configuration. Voila, and now we have the content back. So as the next step, what I use most often is that I use it for exporting and importing back various pandas data frames. Here is a very minimalistic example of a pandas data frame, and to write it to sciencedata.dk I can use the very same syntax. And as a file format I can use either JSON, Feather or CSV. In this case I will use JSON, specify the object, data frame object, and the configuration, the same as above. And it's there. Again, let's check that we are able to read it back. Python. So we have to specify that. We have to specify that we want it back as a data frame and configuration. And we have it back in Python. The same works also for lists. So if we have a list object like here, we can just run sddk, write file, again we can use JSON, object and conf, and it will be there. The same might be used also for Python dictionaries object. What might be quite fun is to use it also for working with figures. So let's put here a very simple figure using matplotlib. This figure is now in this Python variable figure object, and again we can use the same. But what might be very useful to put this file into a folder, into a shared folder, because in that case we will be able later on to use the figure to the file in a blog post, for instance. So let's move to sciencedata.dk and actualize the website, so that now we have more files here, and create a folder. Let's call the folder, for instance, public figures, and now we can write the file into this folder. Write file, so fig png, because we want to export this as a png file, figure object and conf. That would be in the main directory, but we are interested into exporting it actually into the public figures subdirectory, so let's specify it here and run it. So now it's here in public figures fig directory. So let's actually make this folder public. It's possible to do it here this way, and now we have this this URL of the folder, where this link to the folder where the file is located. And now we can move to Markdown, and in Markdown we have this syntax, https science.dk public. Here we put the link, and the name of our file, png. Voila, and the file from science data is here. So now whenever we produce a new figure and export it using this syntax to sciencedata.dk, we can instantly point out to the file name in a blog post in Markdown to get it there. The package and sciencedata.dk might be used for exporting and importing also quite large files. To test this, we will look at import of a dataset of all ancient Roman inscriptions from an epigraphic database Heidelberg, which we have in a data frame saved as a JSON file on sciencedata.dk in a public shared folder. So let's use this for inspect the time it will take as a first command, and then we can just use edhdf because it will be a data frame again, and use this read file and the name of the file, which is this one, JSON, and we want to read it as a data frame object. And in this case we do not use a configuration because the file is public. We will just put here a link to a public folder where the file is located, or code of the public folder where the file is located, like here. And let's print out first 5 rows of the file. So this might take some time because the file has 150 megabytes or something like that. And we have to move it from one location to other location. For some reason we do not see the output here. Yeah, probably because of the time command, but it's here. As a next step, I want to show you how it works in the case of shared folder. On sciencedata.dk, each folder, even the shared folder, has to be owned by someone, and this owner of a folder can share the folder with some other users. So let's move to the web interface of sciencedata.dk and create here a shared folder for a team. So team folder. So it's here. We are now in my personal space as a user at the University of West Bohemia, but I can share this folder with someone else, with me as a user at the Aarhus University. I could add here any number of people and other users using sciencedata.dk as I would wish. So now we have this folder. We can move back to Python and make a configuration of a session which will use this shared folder by default. We will specify that to make this working, we can specify this folder here, and here we have to specify the owner of the folder. So that's me from the University of West Bohemia. Now I have to log in to the folder using this time my credentials as an owner of the folder, and now have an endpoint natively accessing this folder. So let's try to write a file there. Let's produce a string file. So this is a string object, and it is its content. and write file, string file. It will be a txt file. The data will be the string object, and let's use the configuration from the cell above. Yeah, and the file is now in this theme folder. So let's try to use this configuration, but this time to log in as an ordinary user of the folder. That means me as a user at the Aarhus University. Here the login and password. I probably made a wrong username. Yes, but now I am there, and you can see that even if I run the same command for configuration, I have now a different endpoint as an ordinary user. So let's try to upload back the file from this folder. Read file and string file txt. We want to read it as a string, and we want to use the configuration from the cell above, and it's back. And finally, let's try to write there a new file as ordinary users. Write file, string file 2 txt, and as a content of the second file, it's normal string, like here, no underscores needed. It's useless, and use the configuration from above. Yes, and it's there, is this theme folder, the file. So, and we can inspect it in the web interface. Let's move to this theme folder, and now we can see there both files together. So this is very practical for teams, and especially when you have large files you do not like to send there and back between different local machines. You can upload them just there, and another user can easily load them into his or her own environment. And in the case of JSON, it might easily be R, for instance, or some other programming language, so independent of the environment you are using. So these are the basic functions, and I hope that it will be useful for you. First look into sciencedata.dk documentation, perhaps into the development documentation of sciencedata.dk, and then you can easily start to use this Python package for writing files there and read them back into your Python environment.